So the inverse sine is going to find values in one of these two quadrants right here. So when we take the inverse sine of this ratio, we do get that 0.4194 approximately in the negative direction. Okay, so if we measure that out, here from here to here is negative 0.4194. So that was the rotation we saw in our calculators. Okay, but we're being asked to identify the angle that falls in quadrant 3 here. Okay, so in quadrant 3, we have to see what angle has that exact same sine. Well, the sine is the y value, so we're looking at this point right here. So if I looked at this angle from here to here, that is the angle that has the exact same sine as this, the 0.4194. Okay, and so in order for me to find this angle measure, what I have to use is reference angles, just like we did for coterminal type of angles as well. If I know that this reference angle here is 0.4194, that means that this one is also going to be 0.4194. But it's going to be 0.4194 from what value? From here, pi plus another 0.4194. And so that's going to give me the calculation that I'm looking for. So if I took pi and I added this measure here, get rid of the negative sign, I would get my answer 3.5610 if I round it up. 3.5610. So this is the radian measure that I'm looking for that has the same sign here. And once again, you can confirm that by typing it in. If I measure the sine of 3.5610, it should give me that ratio that I'm looking for, negative 0.4072. So it gives me the correct value. You can confirm your answers for those. Take this second example, the inverse cosine of 0.6095. Okay, so cosine is going to give you angles that fall in quadrants 1 and 2. Okay, but you want the one that falls in quadrant 4. Okay, so here's when you calculate the inverse cosine of this, it's going to give you one in quadrant 1, but you need to find what this corresponding point here in quadrant 4 is. Okay, so if we calculate what we're looking for, we take the inverse cosine of this ratio, 0.6095, and we solve. We get our answer to be 0.9154. So that's this angle right here. Okay, so 0.9154 radians is the angle that I'm looking for. Okay, but I'm not looking in quadrant 1, I'm looking here in quadrant 4. So to find this whole angle from here all the way through this point that has the same cosine or same x coordinate on the unit circle, I can find it by going through this full rotation from here and then removing this much of it. So here I'm going to take 2 pi and remove 0.9154, and that gives me the answer I'm looking for. So here I'll take 2 pi minus that quantity, and when I do, I get 5.3678. And that would be my solution. Now, I can confirm it. Okay, before you hit submit, when you're entering this, if you want, you can check it really quickly by taking the cosine of that angle and enter, and you get 0.6095. Okay, the final one here, cosine. When you're identifying, when you're calculating the cosine is going to give you quadrants 4 and 1. You want to find the one in quadrant 2, however, or this tangent. So here, when you're looking at the given angle of inverse tan of that ratio and negative 0.1297, you get the angle of 0.1290 in the negative direction. Okay, so again, it's rotating here in the negative direction down. Okay, and so, or 1.1290, sorry. Okay, so when you're looking at that, you want to find what the corresponding angle is over here in quadrant 2. So it's this whole angle measure. Well, if you use this reference angle right here, is also going to be your reference angle here of 0.1290. You're able to identify, to get this angle, we go all the way down to pi, and then back up this reference angle. So pi minus that is going to give us our overall angle measure. And so if we calculate pi minus this quantity, again, get rid of that negative, I get my answer, 3.0126. And that's my answer. I can verify it if I take the tangent of that 3.0126. It should give me the same decimal, -0.1297. So it confirms that I got the right solution.